Okay, these are the two problems that I did not finish in class for you guys. So I told you I would work them out, explain them for you, and post them in Schoology. So hopefully you will be looking for these. So here's one question, fair game. And again, this is out of your notes that we worked on in class. So 5 cards, each with a different symbol, are shuffled and you choose one. If it is the diamond, you win $5. The cards are reshuffled after each draw. You must pay $1 for each selection. You continue to play until you select the diamond. Is this a fair game? I.e., on the average, will you win the same amount as you lose? So there's lots of different ways you can assign this. Basically, you're either going to win or you're going to lose. So I'm going to say 0 and 1 is that I get a diamond, and so I win. And then 2 through 9 is going to be everything that's not a diamond, and I lose. You could go as far as to say 2 and 3 is a star, and 4 and 5 is a hexagon, and 6 and 7 is a circle, and 8 and 9 is a triangle, but it's completely unnecessary. It doesn't matter what else you get. It's just that a diamond lets you win, and anything else lets you lose. So hopefully my assignment makes sense to you. I'm going to do 0 and 1 is a win, and 2 and 9 is a loss. I'm going to lose. Okay, step 2 is when do I stop? So you're going to read 1 digit at a time, which represents the card, and you're going to stop after a 0 or a 1. So you don't stop until you win. You keep buying cards until you win. And then step 3 is you count. So how much did you win or how much did you lose? And so the very first card I pull is a 1, and so it's a diamond. You might be saying, why does she have +4 written up there? Well, remember I have to pay $1 just to get the card. So I paid them $1, I got the card, it's a 1, so it's a diamond, so I win $5. So what I've written above each of my trials is how much I profited in that trial. So in the very first trial, I profited $4 because again, I paid $1 to buy the card and then they gave me $5 for my winnings. So I profited $4. The second trial, I get a 2 and I lose, I get a 9 and I lose, I get a 7 and I lose, and I get a 5 and I lose, and I get a 1 and I lose. And so I had to buy 5 cards before I even won. So I paid them $5 and then they paid me back $5 basically. So that's why I have +0. I just broke even. I didn't win anything, I didn't lose anything because I had paid $5 to play the game before I even got $5. The same thing happens on the third trial. And so 3 is a lose, 2 is a lose, 5 is a lose, 8 lose. So 1 I win, and again I bought 5 cards and I win $5. So again I profited 0. Okay, on the fourth trial, I only have to buy 2 cards before I win. So 3 is a loss and then 0 is a win. And so I paid $2 to play and I won $5. So that's a profit of $3. Okay, and you're going to keep doing that. You're actually going to do it 20 times, it says. And so I should have really, in my stopping, I should have said read 1 digit at a time, stop after a 0 or a 1, which is a win, and you want to do 20 trials according to the instructions. So I didn't write that down. But anyway, so I continued on doing that. Notice the next one. Let's see, 1, 2, 3, 4. The fifth trial here took me 5 cards before I win, so I have a +0. Go to the next one, and it takes 1, 2, 3, 4, 5, 6, 7 cards before I win. So I pay out $7 and I only win 5. So notice that now my winnings start becoming negative. I paid $7 to play and I only won $5. So I profited -2, like I lost $2. So I continued that and did that for 20 trials. And so at the end of the 20 trials, I need to figure out how much on average I win, because it says after the 20 trials, how much did you win or how much did you lose? And so on your calculator, you need to find the average of all those numbers. So you can add them up and divide by 20. You can put them in a list and then run the one variable calc on it. Do one variable calc and get the average from that. I'm going to do it in a list just because I like to keep things very organized. So I've got +4. Oh, sorry. Let me clear out my list really quick because I've got some old data in there. And go again. Okay, so I'm going to put all of my money amounts that I won for each trial. So first one, I got a 4. Second one, I have a 0. Next one, I have a 0. And then a 3. And then a 0. And then a -2. I have a +3, a +2, a +4, a +4, a +2, a +4. I'm finished with the first row, so I'm moving on down to the next row. -17, +4, -1, +2, +1, -10, -7, and then positive, and then 0. So those are my 20 outcomes of whether I won or I lost. I'm going to go to Stat, over to Calc, one variable Stats, and I want to calculate it. And my X bar, remember, is the average amount that I won. So on average, I'm at -0.2. And if you added them all up and divided by 20, you would also get -0.2. So what does that mean? On average, I lost 20 cents. On average, because sometimes I won, sometimes I lost a lot. Like one of the times I lost $17. And so on average, you lose 20 cents. So is the game fair? No, it's not fair. How do we know if a game is fair? A game is fair is if you break even. It's actually if you're expected to win $0. That's a fair game. And we'll learn more about expected value in our next section. But I just want you to know, is a game fair? No, it's not fair if either side is profiting. So if you break even, if it's 0, then that's a fair game. Okay? So next example, this is the last one here. Fair or not, still, someone proposes the following wager. You and the other person, independently of each other, are each to draw a random number from 00 to 99. If the sum of the two numbers drawn is in the range from 00 to 99, then you receive $10. Otherwise, so if it's not 00 to 99, so if it's anything else, it's going to end up being a sum of 100 to 198. But anyway, if it's anything else, then you have to pay the other person $10. Is this a fair wager? Start at line 110 of the random digit table to answer the question. It said do 30 simulations, but then later on in step 4 it says to do 20 simulations. So let's just do 20 simulations, okay? They did give us enough rows to do 30 simulations, but let's just do 20 and we'll be all right. So step 1 is assign. We've kind of already been assigned that you're going to be doing digits 00 to 99 for each of you. So you're reading 2 digits at a time, but you need to do a set of two digits. So for a total of 4 digits. So like on the very first trial, like I get a 38, you get a 44, we add them together, the sum is 82. So since the sum is between 00 and 99, I win that one. So you're going to win if it's 00 to 99. I'm going to win, excuse me, if it's 00 to 99. The other person's going to win if it is 100 to 198, because those would be the other possibilities. So I win $10 if the sum is 00 to 99. I lose $10 if it's 100 through 198. So again, for the stopping, you're going to read, you're going to add the 2 sets of digits 2 at a time together to make 1 trial. And then you want to count how many times you won out of your total 20 trials. So 38 and 44 gave me the 82, and that is a win. I went ahead and highlighted all of my wins. So anything between 00 and 99 did get highlighted. Okay, to get the 171, what did I do? I did 84 plus 87. 84 plus 87 is 171, but that's a loss for me. And then 89 plus 18 is 107. That's a loss for me. 33 plus 82 is 115. That's a loss for me. 46 plus 97 is 143. That's a loss for me. 39 plus 36 is 75. That's a win for me. So then 44 plus 20 is 64. That's a win. 06, so that's 6 plus 76 is 82. That's a win for me. 68 plus 80 is 148, and so that's a loss. 87 plus 08 is 95, so that is a win. Next row, I have 81 plus 48 is too much. It's 129. That's a loss. 66 plus 94 is 160, so that's a loss. 87 plus 60 is 147, so that's a loss. 51 plus 30 is a win of 81. 92 plus 97 is a loss because that's a sum of over 99. That's 189. 00 plus 41 is only a sum of 41, so of course I win. 27 plus 12 is 39, so I win. 38 plus 27 is a sum of 65, so I win. 64 plus 93 is 157, so I lose. 99 plus 50 is 149, so I lose. And so I count up, that's 20 trials, and so I count up how many highlighted or circled ones I have now, and that would be 9 of them. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 out of the 20 times I won the game. So that means I lost 11 out of 20 times. Is it a fair wager? Based on this simulation, no, it is not. If we did it again and we got 10 out of 20, then we would say it was a fair wager because we would win 10 and we would lose 10. So we would end up breaking even at the end of the game. But since we win 9 and we lose 11, that's going to be an unfair game. That's not a fair wager.